All right. In this video, we're going to talk about files and exceptions. And if we have more time, we'll talk, get into the classes and objects. And classes and objects are a bit more advanced than the other topics that we talked about. But I still want to go through the finishing up, uh, you know, files, exceptions, and perhaps a little bit more of the, you know, the bouncing ball project that we've been doing. So we'll do some of those, and then I probably uh, introduce the second project possibly for you guys to consider. That will be the statement project. Okay, so let me. So those are the agenda. This is going to be a recorded, asynchronous recorded lecture. Then we'll come back on Monday to discuss more details, and you can ask questions on Monday sessions. But I need you to watch this before you come to class on Monday. Okay, so I will probably send you an email, and then you guys, know exactly what these links are. So, okay. So let me share my screen. So I want to discuss the opening of file and reading and the writing files. Okay, so this is the one way to, if you have the file, the Python can read and write files to the one that you're going to designate. So I'm going to bring up, we talked about the, modules last time. So this is not same as the module. Okay, modules are something that you create with the, different functions, a list and all that stuff, so that you can combine those two to use it outside. But this is just the files that you already have, or the you want to write it somewhere. Okay, so that's what the this file is going to do. All right. So in order to open a file, okay, let me just go here. I'm going to share this. So you're just going to have to say, in this case, my name of the file is the test underscore file. And then you say open. Then you give the path that where the files that you want to open. So mine is the in my directory. So yours may be different. So I have some file that I want to read from. So then after that, you designate the where the file is, and then you're going to open it by using open command over here. And then you're just going to have to write a text is equal to test underscore file. See right here, that's the name that I file that I named that, and dot read methods. Then you're going to print the text. And the writing is exactly the same way. Now you're just going to have to make sure that where this file is going to get written. Okay, so just like the other one, you're going to open the whatever the file that you have created. Then we're going to use a test underscore file dot write. And I'm just writing this, sentence over here, and then you're going to close it after you write it to a file. So if I run this, okay, I'm going to share this. Okay. So the first part here, okay, these are the you know the file that I am reading. Okay. Oh, sorry. All right. So these are the files that I am reading from the first part that you see. The path that I have designated. Okay. So as you can see that I am reading, the path that I have designated here, as you can see. And then, I also wrote to a file, right? So if you go to the file that I have written, okay, and that, you can see that this is what I wrote from the Python file, and that's what you're seeing here. So there is the way that you can, write and read. I'm going to ask you to try this. Okay. I want you to create, a file and read it, and then, this will be a, in-class exercise. You're probably going to see one of these after this video. You will have some exercise that you need to do. Okay. So that's just going to be the way to read and write, files using Python there. Okay. All right. Next thing that we want to, study is called the exceptions. We have a lot of syntax errors that occurs in the Python, and sometimes that the reason for the syntax error is because we're not following the rules that we're supposed to follow, or there's the typo. Okay, like you forgot the colon after the like for loops or the if, or sometimes there's a logical errors that you create, like some that you want to divide something by 0, which is not going to work, right? So syntax errors occur when Python cannot interpret our code since we didn't follow the correct syntax for Python. These are errors you are likely to get when you make a typo, or you just, you are first starting to learn Python, okay? Exceptions occur when unexpected things happen during the execution of a program, even if the code is syntactically correct. So that means like, you write everything correctly, but somehow the logically that doesn't make any sense. Like, case of dividing by 0. So there are different types of built-in exceptions in Python, and you can see which exception is thrown in the error message. Okay. So errors and exceptions, handling input errors. We have, I created something called party planner function, and you will see that in a minute. Below it takes the input a number of party people and the cookies, and figures out how many cookies going to go to each person at the party. Assuming that equitable distribution of cookies, then it returns the number along with the how many cookies will be left over. Now, the idea here is that, okay, if I'm making 20 cookies and the 3 people showing up, then, each person is going to get, 6 cookies, and I'm going to have 2 left over. And that's going to be the idea of a program here. But what if nobody shows up? So that means I'm going to have to divide 20 divided by 0. Now that's error, logical error, right? And in that case, we're just going to have to, tell the user you cannot have 0 people showing up here, right? So right now, calling the function with the input of 0 people will cause an error because it creates the 0 division error exception. Okay. and edit the party planner functions to handle this invalid input. If it runs into this exception, it should print a warning message to user and request they input a different number of people. So after you have edited the function, try running the file again and make sure it does what you intend. Try it with the several different input values, including the 0 and other values for the number of people. So what we're going to do here is that I have created the file. Okay. So I'm going to share with that. There you go. So let's just look at this file that I written here. So if you look at the first one there, right? This is the function of the party planner. And then we're going to have arguments, cookies, and people. Okay, so right now we don't have leftovers and we don't know how many people is going to show up. And if you have, right now we're going to have, depends on how many cookies you're going to make, and we're going to divide it by how many people are going to show up, right? And after that, we're going to, return the values, how many people is going to get each cookies and how many going to be leftovers. So right now that, that's the function. So we're going to call that function, okay, the party planner there, right? So we're going to use this function in the main function over here. So we're going to let a party equals to y, while party is equal to y. Cookies is going to be integer, and this is just the main program that interacting with the users, and based on the input that we're getting from users, then we're going to execute that function over there. So cookies gonna, we're gonna ask, how many cookies you're going to bake, and we're gonna also ask how many people are coming. So the next line that here you see is cookies each and leftovers. So we want to find out how many cookies are going to go to each, person who coming, and how many is going to left over. Then that's going to be the function that we are going to execute over here. So that's why you see party planner, cookies, and people. Now we're going to have to, be careful here, because we're going to have to remember, right, that you cannot have a 0% that coming in, because if you are dividing anything by 0, you're going to get some error. So what the if statement is going to do here is that we're going to write out how many people are attending, then how many cookies we're going to have each person, and how many is going to left over. So that's what the if statements are doing, and then we're going to print out the messages there. Okay. Now so I'm just going to run this now. If you see something in the middle that I kind of blocked it out, like commented out, so don't worry about that yet. So right now we have two, this is going to be the function that we're going to call down here. Okay, and this is going to be our main functions and the interaction between the users, right? So let's just run this. Okay, so how many cookies are you baking? I'm going to say 20. Okay, maybe I should give you guys this one here. And how many people are attending? Let's say 3. All right, then what happened here is that they the Python execute the main function right here. Let me go back here. So what happened now is that okay, hang on a second. So right now the I add, when they ask me how many cookies am I baking? So I say 20. How many people are coming? So I, enter 3. And then we have cookies and the people. So these information is going to be, received from these two here. And then we are going to pass that information to the party planner, which is the function that we have here. And this is going to be what we call the calculator. This is where that everything is going to get calculated. And after that, right, whatever the information that we're getting from there, and we are going to print it over here. And of course, then there's how many people are attending, how many cookies are going to be, have, and how many is going to be left over. So if you go to the other one that I just did, that's what's happening here. So when you look at the inside the if statement, we'll have how many people attending? Well, that's going to be 3, right? That's the first one, that we have, because that's how many people are attending, right? And then they will have each with the how many cookies, and they're going to have 6 cookies, right? Because when you look at the left number of each and the leftovers, that's the one that's going to get returned, right? And the after that, we're going to have how many leftovers, is whatever that's going to be. So 2 leftovers, I think, right? Okay, good. So what we're seeing here is that we are, accessing this function over here to, calculate how many, cookies for the each person, and then the how many left over, and how many people are attending. So now you have to be careful here, though, right? Because the when you try to write, right, we're going to have if you go back to the statement that I have a message equals to, we'll have number of people attending, and they'll each get the number of cookies and the leftover, right? So these are all going to be coming from the other function, right, that we just created on the top. Okay, so you're gonna have to make sure that what comes where. Okay, because the when you look at the return statement from the function party planner, we are expecting a number of each. That's how many cookies that people are going to get. So, and then after that's going to be leftovers. So we're going to have to be careful about, what we need to, how we want to print this thing out, right? So everything is fine, but what if, I accidentally, let's say, I put 0 in there. So let's say, how many cookies I'm baking? 20 again. Then I decided, okay, no one's coming, 0. So we're getting an error. It says if you look at the bottom of this, it's called the 0 division error. Okay. It says integer division or modulo by 0. Then in other words that you are trying to divide this thing by 0. So, you cannot do that. So in our case, what we want to do here is that we want to control these errors here. Sometimes that, I mean, this is going to be fine, as long as you know what error it is, because, if some people just read this, who had no idea what's going on, then, I don't know what's going on here. It doesn't say anything. It just say integer division or modulo by 0. What does that mean? This is the one case, but there will be some other case that you cannot, some of these system errors, you cannot explain this, okay? Because it would be more like a genetic type of errors that, the system will print. So what we want to do here is we want to control these errors, and that's where the exception is going to come in. Okay, so let me go back to the input recording coding here. So what we want to do here is that instead of, just to, let the system give us the genetic errors, we are going to write exceptions. Okay, so here is the where we're going to write. So I'm just commenting these out. So we're going to use the other one that I have here. So what we are going to do here is that we are going to do some sort of a control of when we face this type of error. Okay, we know that we know how to handle this. Okay, so if you if you look at this block of code here, it's pretty much the same as what you see up here, except okay, I am putting everything in what we call try block. Okay, so if you see the try, and what the except means that there will be some kind of error that what system error that will be generated. Now instead I am going to control that errors by writing my own warning messages. Okay, so what happens here is that if you look at the what we call zero division error, that's what the Python will generate if you say 0 divided by 0. But because I made the exception, that we call the exception is a thrown. So whenever the you put in exceptions, now you are creating your own message to the users that, hey, more friendly way of telling users you made the logical errors instead of just the system generated genetic errors that you don't understand what they're talking about, right? So in this case, we are controlling the the errors that will be logical errors, especially that will be created by the system. So we're trying to prevent that by writing your own. So if you look at the program here, it's pretty much the same. You got leftovers none, num each none. Then you got num each cookies, divided by people. Then leftovers cookies divided by people, and so on. So the only thing that we did here is to add an exceptions. Okay, and what that means here is simply if you make some kind of like in this case logical errors, we're going to give you a warning, and rather than you receiving the genetic Python errors, you're going to get the error that I wrote. All right, so let's see, run this, see what happens here. Okay, all right, what happened? Oh, okay, sorry. All right, let me just run this again. I think, hang on, let me just do this. I don't know what happened here. I think, give me a second. Let me see. I thought I had that. Okay. Here's what I'm going to do. Huh? Is this one I just did? Oh, crap. Hang on. Let me try this. No, not that one. Okay. Let me try this way. I think I made some space. Okay. Let me make a corrections here. All right, let's see. Where? Did I go too far? Okay, hang on a second. Leftover num. Oh, okay. Sorry about that. Okay, I think. Yeah. Yes. Give me a second. Let's try this guy here. Oh, sorry. Return is on there. Okay. Okay. Wait. Oh. Hang on a second. Okay. Okay. Trying to fix this. Hang on a second. Hang on. Okay. I'll be right back. Let me fix this up. I'll come back. All right. Sorry about that. Let me go back to the share screen here. Okay. So this function here now is applying the exceptions. Like I said, the only difference from the previous function here is that we add the exceptions. Okay, so in order to do that, you're going to have to say try, and then you're going to have to say exception and whatever the genetic functions that you want to print. Okay, is that you're going to have to I don't know how many different errors you can have. So what I am saying here is that when the Python reads the except here, it needs to refer to some sort of a genetic error in the library. So if you go to the error descriptions in the Python library, it will have a 0 division error. So there will be some other different errors that we're going to have to use in the place of 0 division error, but we don't want to get into too much detail on the exceptions. You probably, I mean, if you're understanding what it is going to be the best. Now you can go into the exception a little bit further to find out, what are the errors that you can use to put them into the, try block there. So right now we are using the zero division error. And once the Python comes down this line, then it's gonna, it knows that it's gonna be the zero division error in this library. Okay, and then it's going to print. So if you come down here, so if I run this, okay, let me just go here, and the output. Now, if you want to compare this one, now this one is exactly the same. I bake 20, and then no one's coming at 0. Now, if I don't have any try block, then this is going to be the error that you're going to get genetically from the Python. Now, that error is now being controlled now. So I put the 0. So then I had, oops, you enter 0, people will be attending. So this is going to be my try block exceptions that has been thrown here. Okay, so as you can see, you are not going to see the genetic error by, Python, but rather you're going to see the on my own error that, being generated from the function when it gets to that line, zero division error. Okay, so that's how the exception is working. Why do we need to use this? Let me just go to the PowerPoint. So after you have edited the function, try running the file again and make sure it does what you intended. So try it with the several different input values, including the 0 and other values for the number of people. In some pages in our class, okay. Whoops, okay. So this is what we have done here. So let me just go down to the exception here. Okay. Okay. So in conclusions, right? Accessing error messages, when you can handle an exception, you can still access its error message like this, right? And this would print something like this. Zero division error occurred, integer division, or that's what you just saw. So you can still access error messages even if you handle them to keep your program from crashing. So what he's saying here is that if you don't have try block like this we just saw here, even though you have made some critical errors, if you put them into the try block, it's not going to crash. That's what we're saying here. So if you want to compare this one to the other one that we did here, right? This is what the exception there. But in this case, we kind of did it different way, but that's okay. You can still, you can still access the messages. Okay, so you can do it two different ways there. So if you don't have specific error you are handling, you can still access the message like this, right? So in other words that, we, in this case, we specify that it's going to be zero division error, right? But sometimes, you don't know what's going on there. I don't know what is the what kind of error that we're going to have. So you can say something like try, then exception as E. So you don't know what it is, but you're just going to throw something out there. Okay, and what's going to happen here is that Python will probably going to find out what kind of error that it is, and it's going to give you that. Okay, so uh, it's a little bit more complicated because now we are dealing with the you know learning about the preventing your program from crashing, so that because if that happens, you don't know what happened there. So in this case, we're just trying to manage the program from crashing, okay, by the put them into the try block so we can manage the errors and stuff here. So I just want to mention that if you the difference between the one that I just showed you and this one is that this one we actually told the Python what kind of error that we're going to face here. But over here, I'm just calling it, I don't know what it is, you tell me. Okay, so then the once the Python goes through the program, if they come down here and there's an exception, then we don't know what it is, but Python does. So then it's going to print out, okay, and so we can print that out, what kind of exception that we have there, okay. So exception is just the base class for all built-in exceptions. Now we're going to have to get into the class now. So we're going to be coming back probably something like this when we go through some of the coding process here. Okay. So why are we using the exceptions? To manage the program from crashing. Okay. Manage the errors while you are running the program there. Okay. We want to go into the area called the object-oriented programming. Okay, so object-oriented programming is very important. Whatever that we have seen thus far is what we call procedural language. Okay, in other words, that it's going to be A is dependent upon B, and B is dependent upon C, and so on. So if you want to fix everything, then you're going to have to pull out everything. The idea of a class and object is what we call the we have a lot of different things that we are going to go through, but mostly that we want to use the classes and objects is for encapsulations and what we call polymorphism. We're going to talk about that in a minute, but this is just the beginning of what we call classes. And if this is something that going over your head, we're going to come back and over again and come back to this classes and objects here. So we're going to come back to this one, but let's just understand what the classes and objects are. Okay, so we're not going to write any program, but we're just going to have to understand what that means, what do you mean by classes and objects and so on. Okay, so here's the I have things. Okay, and then these things are separated into two different things. One is the inanimate, and the other one is animate. Okay, and from the animate we have animals. Then the below animals we have mammals, and below mammals we have lions. That kind of makes sense, right? Animals are mammals, right? And the mammals are lions, hyenas, giraffe, and all this stuff here. And the inanimate is something that is not animal or whatever. So maybe a sidewalk or the automobiles and things like that. Okay, so I kind of classify the things into two different areas here. Okay. So in Python, objects are defined by classes. Okay. Let me explain how do we understand the class. Classes are more like a blueprint. Okay. So let's say you want to build a house. So you have a blueprint, right? So what goes where, and you don't actually call the blueprint a house, right? But this is the something that you want to use, and the for building house or something, right? And then what the objects are is something that is composed, whatever that house, okay. You're gonna have a bathroom, bedroom, garage, and things like that. And those are gonna be my objects. Okay, so objects are defined by classes, which we can think of as a way to classify objects into groups. So in other words, we can think of classes as a blueprint of the house and objects as a living room, bedroom, and etc. Okay. We are going to name the class, and if you're not going to do anything inside the class, then we're just going to say pass. Okay, so there's no information inside that class. So the pass is used when we want to provide a class or function, but don't want to fill that details at the moment. Let's say I create some class called, I don't know, lion, but at the moment I don't know what to put in there, so I'm just going to say pass. Children and parents. This is going to be another one that you're going to have to remember. If a class is part of another class, then it is a child of that class. And the other class is its parent. So to tell Python that class is a child of another class, we add the name of the parent class in parentheses after the name of our new class. Okay? Like this. So we have, this is the one that we've been looking at this. I want to make sure that I am sharing this with you guys. Yes, I am, right? Okay. So what we did here is that now class things. Okay, so that's going to be the class things here. And then the class inanimate. So what we're saying here is that I create another class called inanimate, but the parent is the things. Okay, same thing for the class animate. Okay, parent is the things. As you can see that in this class, I don't have anything to put in there yet, so I just say pass. Okay. And if you look at the, for example, like, class lions, its parents is going to be the mammals, right? That's what we have designed it in the beginning now. So you're just going to have to write, if the classes that you're going to create is, and you have a parents, you're just going to type the parent in the parentheses. Now, we're going to learn something called inheritance, and that's going to be the one that deals with the parent and child and things like that. Okay. So there are a couple of things you're going to have to remember. Class is going to be more like a blueprint, and the objects are something called like bedroom and garage and things like that. And when you create the class, if you don't have anything in the class, then you just say pass. If you want to create the child class from its parent, you're just going to have to mention the parent using the parentheses and make sure you put the parent's name inside the parentheses. Okay. So here comes the what we call objects to the class. Okay, so now you create some class, right? And the class is just the holding some information there. So within the class, you're going to have some different things like, functions and whatever. Okay. So in order to use the functionality of the class, you have to create what we call the objects. Okay. So let's say I have, I do have a lions class that I just created, right? And I'm going to assign that to Simba. So this code right here tells the Python to create an object in the lions. Remember, the lions is a class, okay? And they assign it to the variable Simba, like a function, yeah. And the class name is followed by the parentheses, okay? So here's the, the functions of classes. So I create the class, my class, but within the class, and I remember that, creating classes like this one is pretty similar to the creating of functions, right? Except we have, instead of having a DEF, now we have a class in there. So we still have, colon there. Now within the class, I have a couple of functions that I have written here, okay? So I have one function is called the one class function. And I have, simple, print command there. And the same thing for the second function. And they that also have just simple function of printing. Okay. So what we want to do here is that, we want to look at, some of the, how, the examples of how the, classes and objects are working. Okay. So when you create some functions that is not doing anything, then you just say self in that function, and we don't have any content, you just say pass. Now remember, these animals are the inheriting the properties from, not property, but characteristic from its parent called the animate, and the other three functions that inside the class animals are just a simply function. At the moment, we don't have any contents inside that, okay? Same thing over here, you can add the any characteristic. Now again, the mammals are the inheriting the characteristic of parent class called animals, okay? So what I want to do here is that I want to, look at some of the examples. Before we get to that, why we want to use the classes and objects here. Okay, so we'll go into more detail on how do we construct the classes and objects. I'm going to go through an example here, as you see over here. But let's just understand why we want to use it. Okay, so why use classes and objects when you could just write a normal functions like breathe, move, eat food, and so on? All right, so in short, a Python class is for defining a particular type of object, because Python objects can have both functions and data elements. Python classes define what methods can be used to change the state of an object. They also indicate what attributes the object can have. So non-object oriented programs may be a long list of commands. Okay, and more complex programs will group list commands into functions or subroutines, each of which might perform a particular task. With designs of this sort, it is common for the program's data to be accessible from any part of the program. As the programs grow in size, allowing any functions to modify any piece of data means that bugs can have wide-reaching effects. In other words, that if you use the linear type of a programming, if something goes wrong, then you're in big trouble. In contrast, the object-oriented approach encourages the programmer to place the data where it is not directly accessible by the rest of the program. So we are kind of isolating it. Instead, the data is accessed by calling specially written functions, commonly called methods, which are either bundled in with the data or inherited from class objects. And they act as the intermediates for retrieving or modifying those data. So the big advantage of object-oriented programming is, the accessibility and the security of data. The programming construct that combines the data with a set of methods for accessing and managing those data is called an object. So what's the advantages of object-oriented programming? Maintainability. Object-oriented programming methods make a code more maintainable. Identifying the source of errors is easier because objects are self-contained. Okay, it's not linearly or linked together as a linear stuff here. Reusability. Because objects can contain both data and methods that act on the data, objects can be thought of as self-contained black boxes. This feature makes it easy to reuse code in new systems. Messages provide a predefined interface to an object's data, and the functionality, okay, with this interface, an object can be used in any context. Scalability. Object-oriented programs are also scalable, as an object's interface provides a roadmap for reusing the object in new software and provides all the information needed to replace the object without affecting other code. This way, aging code can be replaced with the faster algorithms and newer technology. So what I want here is to show you some examples of the classes and objects. Okay, so I'm going to show you and explain. Okay, so let's take a look at the classes that I have written over here. And we just saw that the different classes, so class things, inanimate, animate. Now remember that these names in the parentheses are the parent. Okay, so for example, I have a class mammals, which the parent is animals, but here that I have a class lions, parent is going to be the mammals here. So in the class, at class animals, I define the some functions. Okay, breed, move, eat food. Let me just okay. And then again, I have a mammals class. Okay, it's also the parent is the animals, and I kind of wrote the some functions. Simple functions will do that. Now here's the one thing that we are going to be careful here. Now here the Jeffrey here now is going to be my object. I just create the object from the class called giraffe. Okay, if you go to the giraffe over here, where's my, oh here, it's the class of giraffe, and the only function that I have inside that class is going to be eat leaves from the trees, and it's going to print the eating the leaves. So what does that mean? That Jeffrey is now assigned, the giraffes, okay, is now assigned to the Jeffrey there. Now, we're going to have to look this thing carefully here. What does the Jeffrey will do. Okay. We need to be careful about what we have done so far. Okay, so I'm just going to bring this up here now. Okay. So I assign the giraffes class. Jeffrey is now object of the class. It means now the Jeffrey can use any of the functions that we have inside of any these classes here. Now remember that the mammals, okay, inherits all the characteristic of the animals. So in other words, that whatever the class animals has inside that one, okay, like you have breathe, move, eat food. These characteristics can be inherited to the mammals, because mammal is the inheriting all the characteristic from the animals. Now the mammals can have all these functions can be used from the objects that derive from the mammal class. Okay. So if you look at the these two here now, Jeffrey is now objects of the class called giraffes. So Jeffrey can use any functions inside the class or any whatever that we have within the class. Okay, as long as the you define the whatever the functions or stuff that you want to use inside the class is within the within the class that you are going to use. So in this case, I said Jeffrey. Now, so if you want to, use the Jeffrey, okay. Now let me just go back here. Maybe the you're not really understand what I'm talking about here. So let me go back here. Explain what I'm saying here. Okay. So here. All right. So we are going to assign the giraffes to the Jeffrey. Now this Jeffrey has to be small, lowercase. As I said, Jeffrey is an object. What it means here is that now the object is more like driving something, or the class is kind of let's say house. Okay. And then you can consider the Jeffrey in this case called object, your car. Okay. So the Jeffrey over here is an object of the class called the giraffes. Okay. Now, since the Jeffrey is an object of a class called giraffes, he can have all the access to the that belongs to the class called giraffes. Okay. So because the Jeffrey is an object, we can call functions provided by his class. In this case, giraffe's class, right? And its parent class, because the giraffe's parent is going to be the mammals. So whatever the mammals we have, and plus the whatever the giraffe class has, Jeffrey can access all those information there. Okay, so we call functions on an object by using the dot operator. So you have an object, then you put type in dot, then you access all the functions and information that you want to access from these classes here. And that's what I mean by that. If you go back to the classes here. So here I assign the Jeffrey is my object, and then it's of the called the giraffes class. So now the Jeffrey has all the access of information within that giraffes class, plus the giraffe's parent class. Same thing over here. Harold now is the also an object and of giraffes class. Now you can have all the information inside the giraffes and the its parent class. So when I say Jeffrey.move, it means that I am using the functions, methods, and whatever inside the class. So if you go here, oh, but Jeffrey was the object of a giraffes class. Yes, but if you look at the giraffes class, it also inherit the, in other words, that its parent class is mammals. And when you go to the mammals, mammal is also the class, and its parent is animals. So whatever that the functions that I want to use from animals, mammals, and the giraffe class itself, I can access all those information if I want to. So in order to do that, we're going to put type in dot. Then I'm going to use the move. Now move is not inside the giraffes class, but it is within animals class. But animals are the class that we can use because the giraffes parent is a mammal and mammal's parent is going to be animals, right? So they are all what we call inherited. So this is okay. So we can use the move function. Now, remember the Harold is also an object of a giraffes class, but this time we are going to access information from the giraffe class. In this case, it lives from the trees, right? Now, self means the simply the it's not the function itself is not going to pass on anything but to itself. Okay, we're probably going to change those, but for now, let's just use the self. So self parameter is a way for one function in the class to call another function in the class, meaning that if you use the self, that's how we're going to access, that functions. So, when we say, Jeffrey dot move, then we have a parenthesis there, right? So we can access that way if you have a self inside the within the move functions. Okay, and that's how we're going to do that. So the self parameter is a way for one function in the class to call another function in the class. Okay, so that's what we have there. Now, let me just finish this. So that's what we have here. So Jeffrey was accessing the information from, I guess, what, grandparents. Okay, because Jeffrey is the objects of a giraffe. Okay, and Harold is going to be accessing that information from mom and dad parents class. I guess I don't know. Okay, giraffes class there. So there is no problem with that. Now we can kind of rewrite the giraffes class. Okay, so we're going to add some more here. Okay, so here's the class giraffes. Okay, inheriting the from mammals. Find the food. Okay. Then we have eat leaves from trees and the dance a jig. Okay. As you can see that we add some more functions. Now the only thing here is that now I am accessing the new function that I just created. This guy here at the bottom, right? And then we should be able to get those. Okay. So let's just go over this a little bit here. I don't know what, maybe I'm repeating myself, but this is the one that we're probably going to talk this thing a little bit more detail next time. But let me just finish this up. Okay, so if you go back down here, we already did that one. Okay, so where am I? Oh, yeah. Okay. All right. So we're going to come back here. If you look at the, when you go back to the, the code that we just did, on the first two lines, we create the variables called Jeffrey and Harold. So I'm kind of repeating myself, but which are objects of the giraffe class. Next, we call move function on Jeffrey, and the Python prints moving on the following line. In the same way, we call eat leaves from trees function on Harold, and the Python prints the eating leaves. If these were real giraffes rather than objects in computer, then one giraffe would be walking and the other would be eating, but that's not the point there. So what I want to do now here is that I want to run this. Okay, so we're probably going to get output on these two. Oh, let me just share this. Okay. So the when I if I run this, the output that I'm going to get here is that the output of these two and output of these two. Okay, so let's just run it and okay, there you go. So let's just compare this. Let me see if I can share this. Here we go. So the first one that, you know what, Jeffrey.move. So you're supposed to print the moving, that's fine. And then I have a Harold.eat leaves from trees and eating leaves, right? And the last one that I was expecting here is that, you know, the function jig function, right? So it will, you know, if you look at the self.move, okay, this one you will get that from, I don't know, I need to, oh yeah, because the, you know, you are calling the function move function from another one, right? Because this is a class called giraffes, and the move function is under the animals. Okay, so it's more like, you know, your grandparents' class, and the you are calling it for 4 times. So if you go to the class animals, you know, you're supposed to print the moving. So you're going to have a moving, 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 moving 4 times. Okay. So what we're going to do when we meet on Monday, I want to spend more time understanding classes and objects, and we're going to spend a lot of time, you know, using classes and objects in Python to you know, write some more program and understanding, you know, nature of, you know, classes and objects more. We're also going to talk about some, you know, inheritance and the polymorphism. Okay, so those will be coming up later. But we are going to understand, you know, classes, objects, you know, so that, you know, you understand why we are using object-oriented programming. Okay, so I'm going to stop here. Then we'll come back next week, and then we'll discuss more of the classes and objects. And I will probably upload the exercise for you guys to do next week. All right. All right, thanks. Make sure that, you know, you guys watch this video before you come to the class on Monday. All right. Good. All right. See you later. Bye-bye.